Day 664 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2716, minimize string length. The difficulty level is easy, so don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the string S, you have two types of operation. Choose an index I, operation 1 is choose an index I in the string and let C be the character in position I. Delete the closest occurrence of C to the left of I if exists. Operation 2 is choose an index I in the string and let C be the character in position I and delete the closest occurrence of C to the right of I if it exists. Your task is to minimize the length of S by performing the above operations 0 or more times. Return an integer denoting the length of the minimized string. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input S equals a string A, B, C. The output is 3. Explanation says, first we're going to use operation 2, and we're going to choose I equals 1. So I equals 1, that's index 1, that's this A right here, right? It says, so C is A. Then we move to S of 2 as it is the closest A character to the right. So remember, operation 2, we're choosing index I in the string. Let C be the character. So in this case, it's A at position I, and we're going to delete the closest occurrence of C to the right of I if it exists. That's operation 2, right? So right now we're looking at this A. So when we find the closest A to the right, that would be this A right here, which is S of 2. Boom, right? Sorry, y'all. This 8 right here is the one we're about to delete with operation 2. It says, then we remove S of 2 as it is the closest A character to the right of S of 1. S becomes A, B, C, right? So let's just do this, bring this over here so y'all can get a better visual representation, right? So boom, we choose this A to perform operation 2 on. So operation 2, we're going to delete the closest A to the right. Boom, which would be this A. After we remove that A, we're left with this. Boom, right here. Boom. Then we're going to do operation 1. Operation 1 is the same thing, except we're going to delete the closest occurrence of C to the left. So in this case, right, it says we choose I equals 1. So C is A. Then we remove S of 0. So right now, I is 1. So this A. So we're going to delete the closest A to the left, right, for operation 1, which is this A right here. Boom. And then S becomes ABC, which is this right here. ABC has a count of 1, 2, 3. So that's how we return this 3 right here. Now, just in case that didn't make sense, y'all, let's take a look at example 2. Once again, I'm going to copy and paste this right here. Over here. Now let's get into it. It says, so in example 2, we have our input S equals a string CBBD. This time the output is 3. Again, it says operation 1, we're going to choose I equals 2. So this time I equals 2. This is index 2 right here. It says, so C is B. Then we remove S of 1 as it is the closest B character to the left of S of 1. S becomes CBD after this. So we're going to choose this one, perform operation 1, meaning we're going to delete the B to the left. After we delete the B to the left, we're left with this right here. Boom. And once again, this has a count of 1, 2, 3. Boom, y'all. So if just in case that didn't make sense, let's take a look at example 3, where we're going to have to perform a little bit more operations. So in example 3, we have our input S equals a string B, A, D, C, A, B. This time the output is 4. So first, hold on, let me copy and paste this again. Bring this over here. Boom. So first we're going to perform operation 1. That means we're deleting to the left. So it says we choose I equals 6. So this would be 0, 1, 2, 3, 4, 5, 6. So that's going to be this A. Boom. So it says C is A. Then we remove S of 2 as it is the closest A character to the left. Boom. So we're choosing this A right here, and we want to find the closest A to the left because we're doing operation 1. So the closest A to the left would be this right here, index 2. Remove it. Boom. After we remove it, it becomes BADCCAB. Boom. That's what we have. Make sure that's what we have. Boom. Then the second operation is going to be operation 2, which means we're going to delete to the right. So now we're going to choose I equals 0. So that's this B right here. And so C is B. Then we remove S of 6 as it is the closest B character to the right of S of 0. S becomes a string BADCCA after this. So we're performing operation 1, operation 2. So we're going to the right. We're working with this B. The closest B to the right would be this B right here. Boom, remove it. Afterwards, we're left with this. Now we're going to perform another operation 2, and we're going to choose I equals 3. So I equals 0, 1, 2, 3. This time I equals C right here. Boom. So C is C. Then we remove S of 4 as it is the closest C character to the right of S of 3. S becomes BADCA. So we're right here, meaning we're going to delete operation, or we're right here, we're using operation 2, meaning we're going to delete the C to the right, which is this, and after we're left with this. Boom. Then finally, but certainly not least, the last operation, operation 1, meaning we'll be deleting to the left. We're going to choose I equals 4. So I equals 0, 1, 2, 3, 4. That's this A right here. So C is A. Then we remove S of 1 as it is the closest A character to the left of S of 4. S becomes a string BDCA. So we're looking at this A. Operation 1 is going to delete this A, and we're left with BDCA. And that has a count of 1, 2, 3, 4. So that's why our output is 4. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we want to do is we're going to create a dictionary that will track the frequency of each character in the string. So we're going to just declare a variable called freq, set that equal to a dictionary. The key is going to be a character, and the value is going to be an integer representing the number of times it has appeared so far. Boom, and we could initialize it with the parentheses like that. Then we're going to start with the total length of the string, and we will reduce this count whenever we encounter duplicate characters. So we're just going to declare a variable called count and set that equal to s.count. Boom. Now we're going to iterate through every character in the string by saying for char and s. We're going to open up the brackets, and we're going to increase the frequency of the current character. If the character does not exist in the dictionary, then it defaults to 0 before incrementing. So that is, we handle that by saying freq square bracket char comma default colon 0 come outside of that plus equals 1. So every time we see this character, right, boom, every time we see it, we're going to keep count over here in our freq dictionary, right? And every time we see it, we're going to start the count at 0. That's the default value of 0, and we're going to add 1 to this count every time we see this character. Boom. Now, if this character has appeared more than once, it means this occurrence is a duplicate, and we reduce the count because duplicates do not increase the minimized string length. So, come right here, and we could just say if freq square bracket char, come outside of that, put the exclamation point to force unwrap it, is greater than 1. Then we'll open up the brackets and we'll decrement count by saying minus equals 1. Now we need to return the number of unique characters, which represents the minimized string length, by coming right here. We can just say return count. Boom, y'all. That's all she wrote. Let's give it a run. Make sure it runs properly. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 35 milliseconds, speech dash % of users. Not too bad. Not too bad at all. Now, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.